Welcome to Math with Professor V, and welcome to the new video lecture series, Algebra Review for the Calculus Student. The first video in this series is going to focus on factoring and limits. So in this video, we're going to go over how to factor out the greatest common factor, factoring by grouping. Then we'll focus on factoring trinomials. And then once we're experts in both those factoring techniques, we're going to apply them in order to evaluate limits. And this is part one. There's a lot of factoring techniques and situations to go over. So there's going to be several videos following up, extending your factoring techniques. But let's just jump right into it. So common factors and factoring by grouping. Whenever you're asked to factor an expression, the first thing you want to do is factor out the greatest common factor. Then once that's handled, you can focus on factoring further if need be. So let's look at example A here. We're just told to factor out the GCF, greatest common factor, from 5x squared and 10. So you just have to sit there and think to yourself, what is the largest factor that both of these terms have in common? What can I pull out from both of them? Well, I can take out a 5. And then that's about it, because there's no other variable on 10 that I could take out. So it's just going to be a short little factoring problem, this first one. So I'm going to take out a 5, and then I have to add some parentheses now and write what's left over. So I'll have x squared plus 2. And you can always check that you factored correctly by just distributing that 5 back through and confirming that you had what you started with. Okay, I know this is probably pretty basic, because if you're watching this, you're a calculus student. But just wanted to start somewhere where we're all comfortable. Okay, example B, we have to factor out the greatest common factor. Now, I have constants here. So amongst the constants, the largest thing that they all have in common is a 4. And then I have various powers of p to the 5th, p to the 6th, p to the 4th. I can't take out any more than what one of the terms has. So p to the 4th is the greatest common factor of p's. And then q squared, q cubed, q to the 7th, I can take out q squared. And then I'm going to put parentheses and write what's left over from each of the terms. So if I take out a 4, this is going to become 2. I'll have 1p left and both the q's are gone. So just 2p. Plus, moving on to the next term, if I take a 4 out, now 16 is going to become 4. I took out 4 of the p's, so I have p squared. And then only q to the first left. Minus, and then if I take out 4 from 12, basically you're just dividing. Then I have 3 left, all the p's are gone, and then I have q to the 5th, you subtract. And that's what we're left with. There we go. How's that so far? Now, on occasion, as we'll look later in the lesson, this expression here will factor further, but none of them do so far. I made sure of it. Okay. Next one, example C, negative 3x squared plus 12x minus 6. Now, I can definitely take out a constant from all three terms. I can't take out any variables. And here's a tip that's going to take you places. Let me tell you, if it's already in descending powers and the leading term is negative, you should take that negative out with everybody, majority of the time. There might be some exceptions, but it'll help you out. So I'm not going to factor out a 3, I'm going to factor out a negative 3. And then I'm left with x squared, got to switch the sign, minus 4x plus 2. Okay, very good. Last one, example D, 3a times 1 minus 4b minus 2c times 1 minus 4b. Now, I want you to think of a similar problem if I had 3ax minus 2cx, and you had to factor that. You would probably say, oh, no problem, Professor V, I got you. They have x in common, so I'll just take that out, and then I have 3a minus 2c. Exactly, beautiful. So I want you to look here, 1 minus 4b is a common factor to both of these terms here, just like x was a common factor. So that's what I'm going to pull out right in front, put it in parentheses, and then what do I have left over? That's right, 3a minus 2c. Okay, now multiplication's commutative, so of course you could have written it the other way around, 3a minus 2c times 1 minus 4b. It makes no difference. Both are equally lovely, all right? But This technique here is the second or middle step when we factor by grouping. So that's what we're going to get into next. So factoring by grouping is often used when you have four terms, and you group them two at a time and pull out the GCF. And then you hope that after that, you still have another common factor. Watch as we try some examples here. So example A, 2mn minus 8n plus 3m minus 12. I'm just going to look at these first two terms and then the second two terms and factor out the GCF from each pair. So 2mn minus 8n, there's a 2 I can pull out and an n, and then I'm left with m minus 4. Good? Whatever sign is between those pairs, just bring it on down. So plus, and then I can take a 3 out, and I have m minus 4 left. These match up, which is necessary. So if they don't, we'll talk about what to do. But basically, I need to have another common factor at this step so I can finish the problem off. And now I can factor out m minus 4, and then I have 2n plus 3. So this is factoring by grouping. Again, when do we use it? Typically when there's four terms involved that we need to factor. There's some exceptions, but that's the majority of the time. Okay, let's try another one. 5m squared plus 15mp minus 2mp minus 6p squared. So again, just look at the first two terms. I can take out a 5 and an m, and then I'm going to have m plus 3p left over. And then be careful here. Whatever sign is in front, you bring that down. And then now you're looking here, 2mp, 6p squared. What can I take out? I could take out a 2 and a p. So the first term, I'm just going to have m left over. And then watch out, since I took a negative out, this is going to switch signs and become positive 3p. Oh, that was a bit of a dangerous moment. So I'm going to put the watch out eyeballs, okay? Now that's perfect because see how we had m plus 3p, m plus 3p. Now I can factor further. If these were not exactly the same, if this was m minus 3p, I'd be stuck. So hopefully that'll help you remember too to change the sign. And then now I'm going to take out that common factor, m plus 3p, and then I have 5m minus 2p left. Bravo. Okay, couple more. So we have a cubed plus 30 plus 6a plus 5a squared. So at first glance, I'm like, we're probably going to have to reorder things because a cubed and 30 don't have any common factors. These two terms do, but that's not helpful if I can't factor something out of the first two. And then I'm looking, I'm like, oh, this guy's not even in descending power, so let's fix that pronto. So a cubed plus 5a squared plus 6a plus 30. Now let's see if things start working out for us. So I can take out an a squared from the first two terms, and then I have a plus 5. Plus, what can we take out here? Very good, a 6. And then we have a plus 5 left. And then now, yep, ding, 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 we're in business. A plus 5 times a squared plus 6. And that one's done. Why don't you pause the video, try the next one on your own. There's a little extra work you have to do in this one. Okay, so if you just start going for it, the way it's written, take out the GCF from the first two terms. You could take out xy, and I have x minus 2, plus 3 times 2 minus x. Now these are not exactly the same. The order of subtraction is reversed. There's one way you could fix it. Here's just a fact. A minus b is equal to the opposite of b minus a. If you were to distribute this negative through, you'd see it's negative b plus a, which is the same as a minus b. So what you could do is switch this order of subtraction around, add an extra negative. But if you weren't aware of that, what else could you do? Well, you could just say, hey, these two are not in the right order. So let me just switch it from the get-go and rewrite things as x squared y minus 2xy minus 3x plus 6. and then proceed to try to factor by grouping. So again, I can take out xy. We have x minus 2. Now I'm going to take out a negative 3, and I have x minus 2. So either way, you got to end up here where you have x minus 2 as a common factor. You could have just switched it and made it negative or reordered the terms. I leave it up to you. I think this just switching, when you look at it, it's more elegant, but not everyone knows to do that. So we've got xy minus 3 times x minus 2, and that one is done. Okay? Good? All right. Remember this method of factoring by grouping, because we're going to get into factoring trinomials now. And for certain trinomials, we're going to utilize this technique, okay? Not right away, but in just a few moments. All right, so now let's get into factoring trinomials. So recall, when we're multiplying two binomials, basically, like for example, x plus 5 times x plus 2, you probably are really comfortable just doing this in your head. Right? When you first learned how to multiply these out, though, you did the FOIL technique, or I don't know what acronym you learned to remember, but you take the first product, then the outer product, inner product. That was my alarm, but I'm already up. And then last product. And then you end up with x squared plus 7x plus 10. And like I said, most of you probably don't even write this out. You can do it in your head. Because what you know to do is take these two constants, add them together. That's the coefficient on x. And then their product gives you the constant term at the end. This is when we're multiplying things out. So when we're factoring, what we're doing is reversing this process. So our task changes. Instead, we're going to be given x squared plus 7x plus 10. And then we have to figure out how to write it in factored form. So there's so many different factoring techniques. I'm going to show you one. If you like it, great, use it. If you like something else, that's fine too. But here I just want to give you something to use in case you're in need of review to help you factor your calculus problems. So a nice way to organize the information, I've seen a lot of students make this X method and they swear by it. So I'll show it to you. You put the constant that's at the very end up top. And then you put the coefficient on x at the bottom. And our job is to find two numbers that multiply to that number on the top, that multiply to 10, and that add to 7. And really, most of the time you can do it in your head. But if you want to just organize the thought process a little bit, it can be helpful to write out that little x. Okay? So let's try factoring these trinomials. It's going to get more complicated, obviously, if the coefficient on x is not 1, and we're going to get into that in a minute. But let's just make sure we're all good at factoring trinomials when the coefficient on x squared is just 1. So factor completely. First one, we have x squared plus 8x plus 15. So if you want to write out the little x, can you think of two numbers that multiply to 15 and add to 8? And you can just kind of start going through your head if it's not jumping out at you. 1 and 15, no. 2 doesn't go into 15, 3 and 5, ding, ding, ding. And they both need to be positive because we have to multiply to positive 15 and add to positive 8. So this is going to factor into x plus 3 times x plus 5. And I would box it so you don't accidentally multiply it back out, you know. Okay, next one, x squared minus 14x minus 72. So can you think of two numbers that multiply to negative 72 and add to negative 14? Sometimes it's not obvious, so just start making a list. What multiplies out to 72? Never mind the negative. We'll deal with that in a minute. So 72, 1 times 72, but there's no way I can add or subtract these two to get 14, so keep it going. Then 2 times 36. Could those give me 14? No. 3 times 24. That won't give me 14. 4 times 18. Ding, ding, ding. Okay, so that will give me negative 14 provided the 18's negative and the 4's positive, which is perfect because then these two will multiply to negative 72 and add to negative 14. And then you're just ready to go. You go, oh, this is x minus 18 and x plus 4. Again, you could have written it the other way around. X plus 4, x minus 18 makes no difference. Good? Okay, let's look at a few more. M squared minus 2m plus 5. So can you think of two numbers that multiply to 5 and add to negative 2? Well, the only numbers that multiply to 5 are 1 and 5 and 5 and 1. And there's no way I can add or subtract those two numbers to get negative 2. So when it's not possible, we say that this expression is prime. It cannot be factored any further. All right, good. Next one, example D, r squared minus 6rs plus 8s squared. So don't worry about this rs and s squared. It'll work itself out when we set things up. Let's just worry about finding the constants that multiply to 8 and add to negative 6. Have you thought it through? Negative 4 and negative 2, right? Very good. So instead of just putting r minus 4, I'm going to have r minus 4s and then r minus 2s. And then you'll see when I multiply this out, this will give me minus 2rs. This will give me minus 4rs, which adds to negative 6rs. And then this would be positive 8s squared. So that one's done. Notice since the last term was positive and the middle one was negative, both of these have to be negative. Okay, E, 2a squared minus 2ab minus 24b squared. So don't forget, the first thing to do is always factor out the GCF, the greatest common factor. Then you proceed with whatever technique's appropriate. And I'm looking, I can take a 2 out from everybody here. So let's do that first. Then I have a squared minus ab minus 12b squared. Okay, so now our task is, can you find two numbers that multiply to negative 12 and that add to negative 1? Negative 12 here, negative 1. So what multiplies to 12? 1 and 12, 2 and 6, nope. 3 and 4, there we go. Ding, ding, ding. Which one needs to be negative? The bigger one. And then just keep that 2 outside the whole time. So you just bring it down, and then you're going to have a plus 3b and a minus 4b. And that's it. Good? Okay, now things get more complicated when the coefficient on the squared term in the front is not 1. We were lucky in this case because we could take the 2 out from everybody, so we ended up with a 1. But what if we do if that's not possible? Well, one method is the AC method for factoring, which ends up taking you to factor by grouping. Another way that it's sometimes referred to is splitting the middle term. There's a bunch of names for this same technique. And then there's other things out there if you have other favorite factoring techniques, the bow tie method or other stuff. So, you know, if you've learned something already and it's working for you, go with it. But if you need some help, here I am. Say we have to factor ax squared plus bx plus c. You're still going to make your little x, okay? It's just that this time up top, you're not going to put c, you're going to put a times c. Which really we were doing this whole time. It's just that a was always 1 for all the previous problems. And then again at the bottom, we're going to put b. And then your task is still to find two numbers that multiplies to AC and that add to b. And then I heard a cute little, when I used to help run a tutoring center, one of the tutors would say this. Up top, you've got the air conditioner in your house, and downstairs beneath everything is that basement. I thought that was so cute. Okay. All right, so our goal is now find two constants whose product is AC and add to B. And then once we've done that, we're not done. You can't go straight to factoring just yet. You got to split BX, split the middle term using the two constants you found, and finish off the problem factoring by grouping. I'll show you exactly what to do. So let's try a warm-up example. Factor 2x squared plus 7x plus 3. So this is A, B, C. Let's make our little x. A times C is 6. B is 7. So can you find two numbers that multiply to 6 and add to 7? 6 and 1. Very good. Now we can't just go straight to factored form. What we're going to do is split the middle term using these two constants. What do I mean by split the middle term? I'm going to rewrite 7x as 6x plus 1x plus 3. So the 6 and the 1 are the constants that I found that multiply to 6 and add to 7. Why do I want to do this? Well, now I have 4 terms, and when we have 4 terms, we factor by grouping. So we take the GCF out from each pair. I could take a 2x out here, and I have x plus 3 left. Bring down that plus. These two have nothing in common, so I'm just going to put a 1, and then you have x plus 3. And then as long as these numbers are correct, it will always work out that you have a common factor here. So then this is x plus 3 times 2x plus 1. And it makes no difference if you put 6x and x or the other way around, x and 6x. It will still factor correctly and completely, just as long as you found the right constants, okay? This method always works if your trinomial is factorable. Okay, I was never taught this as a student. They told me just use trial and error, kind of guess and check. So I will also show you that method, and then we'll talk about when it's best to use which one. And I honestly, most of the time, don't even do this method because I just do it in my head. So let's practice. Like I said, for trinomials with the lead coefficient other than 1, we have 2 methods for factoring. So try both. You may use either. Factor by trial and error. So we're not going to split the middle term right now. I'm just going to show you kind of like guess and check, trial and error, what you can do in your head. You basically reverse engineer the thing. You go 7r squared minus 4r minus 3. First look at that leading term, 7r squared. There's only one way to get 7r squared. That's if you have 7r and r. Then your attention shifts to the last term, which is negative 3. Never mind that it's negative for a hot second. Just go 3. I can only get that by multiplying 1 and 3. So the question really is it 1 and 3, right? Or is it the other way around? How do you know? Well, you just give it a test FOIL in your head, and you go, okay, this would be 7r squared. This would be, oh, holy smokes, 21r and 1r. There's absolutely no way I'm going to get negative 4 with 21 and 1. So I'm thinking this is not the way to go. Then we check here, 7r, 3r. Can I make negative 4r? Yes. If this was negative, so let me put a minus sign right here, and then this would need to be positive. And then that's it. And then we've factored. And when you're good at this, oops, it's actually a lot quicker than the method I just showed you. But you have to kind of get comfortable with it, okay? I want it to box perfectly, and it's just not cooperating. There we go. Let's try another. Are you ready? Okay, so focus on the first term, 5x squared. So that has to be 5x and x. There's no way around that. The last one is 9. Okay. So we've got some options. That could be 9 and 1, 1 and 9, or 3 and 3. So you might play around with it a little bit. 1 and 9. Oh, this looks awful because look, 45x, 1x. Outer, inner, that's what you're multiplying. 45 and 1, no way I can get 12. So then you say, nope, 5x, 9x, 1. This one didn't work. Is this going to be any better? 5x, 9x. Can I get negative 12 out of there? Nope. So then let me try now 3 and 3. So this is 15 and 3. Can you get negative 12? Yes, if this is a negative 15 and this is a positive 3. Boom. And I'm just going to give you a piece of advice. Unless this middle term has like a really, really big coefficient, usually pick the factors for the last one that are closer together. So 1 and 9, 9 and 1, those are so far apart. Most likely it's going to be 3 and 3. Unless you see some huge number here. Hugely big, hugely small, okay? All right. Shall we continue? Yes. So like on that note, see, I look at 6p squared, I go, ooh, That could be 6 and 1 or 2 and 3. But I know usually it's the ones that are closer together. So I'm just going to go for 2 and 3. Okay, I could be wrong. It could be 6 and 1, but I'm just going to give this a shot. And then I'm looking at the last term. It's 10. There's 10 and 1 and 5 and 2. I'm not going to try 10 and 1 first. I'm going to try 5 and 2. And then, yeah, we've got a couple options. Where could it be? So let's just list this twice and see. So either it's 5 and 2 or it's the other way around. Which one's going to work? So this is 4p, 15p. Oh, that works. Look at us, lucky ducks. Let's make sure the other one doesn't. 10p, 6p, 10 and 6. Yeah, no good. Goodbye. All right. One more. Before you get terrified by the large numbers, remember, we can take out a common factor. I could take out a 5y. 5y. Then we have 3y squared plus 11y plus 6. And then you just kind of ignore this poor little 5y, and we focus our attention here. So 3y squared, only way that's going to happen is with 3y and y. And then now I look at 6. It could either be 6 and 1 or 2 and 3. I'm going to try 2 and 3 first. They're closer together. So is it 2 and 3 or 3 and 2? Think it through. See if you can do it without writing it. The 3 has to go here, right? And 2. That way this gives me 9, 2. There's my 11. Okay. Some students pick this up really well. Some hate it with a fiery passion. So, you know, I'm just giving you options. Now, if you don't like this guess and check or trial and error, then I'm going to show you how we can factor all of these with the AC grouping method that I introduced a minute ago. So let's revisit example C, but this time we're going to use the AC grouping method. Okay? Pretend you don't know how it factors. So this is A, B, C. I'm going to set up my X. A times C goes up top, air conditioner, so 60. And then B is in the basement, 19. So can you think of two numbers that multiply to 60 and add to 19? Well, what multiplies to 60? 1 and 60, no. 2 and 30, no. 3 and 20, no. 4 and 15, yes. So 4, 15. Now that I have 4 and 15, I'm going to split the middle term. So I'm going to rewrite this as 6p squared plus 4p plus 15p plus 10. And like I said, you could switch these two around. It won't make any difference. You could put 15p and then 4p. Now I'm going to factor by grouping because I have 4 terms. So I can take out 2p, very good. And I have 3p plus 2. Plus, now I can take out a 5, and I have 3p plus 2. These should match. If they don't, you messed up. Okay? If they don't match, you messed up somewhere when you're factoring using the AC method. Then I take out 3p plus 2, and I have 2p plus 5 left over. Okay. So students like this method because it will always work so long as your trinomial is factorable and it takes out that like guessing element. I like to use it when the constants are just have a lot of options for factors and I don't feel like guess and check is going to be efficient with, you know, it won't be timely. But I don't use it all the time. All right, let's try a few more. And by a few, I mean one more with this method. Oh, 2 more. And then we can move on to doing some calculus problems that we need to factor. Okay, 5x squared minus 12x minus 9. Why don't you pause the video, try this one on your own. So A, B, C. Did you factor it? Okay, let's see. So A times C is negative 45. B is negative 12. So the two numbers that work are negative 15 and 3. Now, like I said, it doesn't matter the ordering, but when one is negative and one is positive, it's easier if you put the negative one first. You don't have to, but it's easier because then you don't have to remember to change the sign on the very last term. Okay, these two have a 5x in common, x minus 3. plus, I could take a 3 out, x minus 3, and there we go. X minus 3 times 5x plus 3. Boom. Did you factor it correctly? Good. Next one, it's not in descending power, so let's reorder things first. It's looking like a hot mess. We have negative 4x to the 5th plus 2x to the 4th plus 30x cubed. So now let me take out the GCF. I can take out a negative, yes, 2x to the 3rd. Then we're left with 2x squared minus x minus 15. Now I'm going to leave it up to you if you want to factor by trial and error, guess and check, or if you want to do the AC method. If you want to do the AC method, then you'll have a times c, so negative 30 up top, and then negative 1 down below. So two numbers that multiply to negative 30 that add to negative 1 are negative 6 and 5. Perfect. So just this negative 2x cubed, he's hanging out, comes along for the ride. And then now I'm going to split the middle term, that negative x, as negative 6x plus 5x minus 15. And then we can factor by grouping in here. Just keep writing negative 2x cubed. I can take out a 2x, and I have x minus 3 plus 5 times x minus 3. No surprise, these match. Remember, if they don't, you messed up. And then we are pretty much done. So keep negative 2x cubed there, x minus 3, and 2x plus 5. Now, I said multiplication is commutative, which is true. So you can reorder how you write these. You can interchange these two, but it's common practice if you just have one term, when you factor out the GCF, put that out front. Don't smush that in the middle or put it at the end. That's not standard way to write your answer. Okay, how do you feel about these factoring techniques? Hopefully good, because now we're going to apply them to finding limits. So evaluating limits that require factoring. So one of the first things in your calculus courses that you're going to cover are limits. If you need an in-depth lecture on limits, I got you. Hop on over to the Calculus 1 video lectures playlist, and I'll also have videos linked in the description here. My purpose is not to go over in this video what a limit is or give you a calculus lecture. It's just to help you practice your factoring skills when finding limits, okay? Just so you can crank it out, no problem. And remember, when we're finding limits and x is approaching some number, you always want to try direct substitution first, where you're just plugging in that value for x. Try direct substitution first, always. The only time you have an issue is when you have 0 over 0, which is an indeterminate form, which most of these will be, and then that's why we need to factor and cancel, okay? So here we go, let's try some limit problems. Like I said, I'm just gonna jump right in. If you need to take a lesson on what a limit is, then go to the description, I got videos for you. So we're looking at the limit as x approaches negative 5 of x squared plus 3x minus 10 over x plus 5. I'm just gonna off to the side try substituting in negative 5 for x. So negative 5 squared plus 3 times negative 5 minus 10 over negative 5 plus 5. And you can always just do this in your head. This is 25 minus 25. That's 0 over 0. Okay. So let's go ahead and factor now. Make sure you write lim every step of the way. So the limit as x approaches negative 5. The numerator factors, can you think of two numbers that multiply to negative 10 and add to 3? Very good. X plus 5 and x minus 2. And then we've got x plus 5 in the denominator. Perfect. I can cancel out x plus 5 now. Still write lim. How do you know when to stop? When you've already substituted in what x is approaching and you don't have any more variables in your limit, but there's still an x here, so I got to write this. Now I can go ahead. If I substitute in -5, I'm going to get a number. So I'll get the limit and I'll be done with the problem. So this is -5 minus 2. See, I'm not writing lim. I'm not writing lim because there's no more variables, which is -7. Okay. Hopefully that one was not too bad for anybody. Next one, limit as x approaches 2. X squared minus 4x plus 4 over x cubed plus 5x squared minus 14x. If I just try to plug in 2 for x first, let's see what happens. 2 squared, that's 4, minus, that'll be 8 plus 4, that's 0. Over 2 cubed, that's 8, plus 20 minus 28. Yep, we've got 0 over 0. So let's try to factor now. So this is the limit. X approaches 2. Can you think of two numbers that multiply to 4 and add to -4? -2 and -2, right? So you could write it as x minus 2 squared, or I'm just going to write it twice. It's easier to see for canceling, but if you want to write it squared, go for it. And then the denominator, before I try to factor the trinomial, let me take the GCF out. I could take an x out, then you have x squared plus 5x minus 14. That factors more, doesn't it? Can you think of two numbers that multiply to -14 and add to 5? +7 and -2, right? Okay. So notice I'm still writing lim. And then now I have x plus 7 and x minus 2. Perfect, perfect, perfect. These cancel. Does that fix things for us? Well, let's see. So now I have the limit. X approaches 2 of x minus 2 over 2 times x plus 7. If I substitute in 2 for x, I'm going to have 2 minus 2 over 2 times 2 plus 7. That's fine. That's 0 over something that's not 0. 2 times 9, 18. So our answer is 0. The limit's 0. The only time that you're worried when there's a 0 in the numerator, if there's also a 0 in the denominator. That's an indeterminate form. Indeterminate meaning we can't figure out what the limit is the way it's written. So we need to factor or do something else. Okay, good, good, good. Moving on. Limit as x approaches 2 of 3x squared minus 5x minus 2 over x squared plus x minus 6. So let's see, if I just plug in 2, that's 12 minus 10 minus 2, 0. 4 plus 2, 6. Yeah, 0 over 0, so no good. That's indeterminate. Let's factor. Now, to factor the numerator, you could do the AC method. I'm just going to do trial and error because 3x squared, the only way that's going to happen is if I have a 3x and an x. And then 2, only way that's going to happen is 2 and 1. So either the 1 is here and the 2 is here, or vice versa. I'm going for a 5 in the middle. So I need the 2 here. That way this will give me 6x. Here's 1x. This one needs to be negative. This one needs to be positive. If you hated that, then you're just going to do the AC method off to the side. So a times c would be -6. b is -5. So can you think of two numbers that multiply to -6 and add to -5? -6 and 1. Watch out, it's not -2 and -3 because -2 and -3 multiply to +6. I know. So then you'd write this as 3x squared minus 6x plus 1x minus 2. Take 3x out. You have x minus 2 left. You can't take anything out, so just put a 1. And then boom, then you're done. X minus 2, 3x plus 1, which is what I have. Okay, good. Then let's focus on the denominator. X squared plus x minus 6. So think of two numbers that multiply to -6, add to 1. It's 3 and -2, right? So x plus 3, x minus 2. Boom, these cancel. So now we've got the limit, x approaches 2 3x plus 1 over x plus 3. Can I evaluate the limit now? Let's see. X is going to 2, so 3 times 2 plus 1, I have 7 over 2 plus 3 is 5. Beautiful, beautiful. Okay, next one. Find the limit as x approaches 1 of 3x squared plus 7x minus 2 over 3x squared minus 4x minus 2. So let's try direct substitution first, see what happens. This is 3 times 1 plus 7 minus 2. That's not 0, huh? Look at that. Over 3 minus 4 minus 2. That's not 0 either. So we don't have to factor anything. We're just going to be done. So that's 10 minus 2 up top over, what is that, negative 1 minus 2, negative 3. So that's 8 over negative 3. Put the negative always outside or in the numerator. Don't leave it in the denominator. So why didn't we have to factor this one? Because it wasn't an indeterminate form. If I tried direct substitution, I was able to come up with the limit. I got some number. It wasn't 0 over 0. So don't factor. You don't need to. Okay, and don't even try. Don't even try. Okay, here we go. Last one. Spiciest one of all. Limit as x approaches 3 of 2x cubed minus 6x squared plus 5x minus 15 over 5x squared minus 12x minus 9. So first, let's try direct substitution. If x goes to 3, you get 0 over 0. I checked for you. You're welcome. Okay, so now we got a factor. How many terms are there in the numerator? There's 4. When there's 4 terms, try factoring by grouping. So we've got the limit as x approaches 3. From the first 2 terms, I can take out 2x squared, and I have x minus 3. Plus, I can take out a 5 here, and I have x minus 3. Okay, now let's look down here. 5x squared minus 12x minus 9. We actually already factored this trinomial earlier. So you can split the middle term or do trial and error. You know which one I love. So 5x squared has to be from multiplying 5x and x. 9 could be 9 and 1 or 3 and 3, but 3 and 3 are closer, so most of the time I try that pair first. 15, 3, yep. This needs to be negative, this needs to be positive. Now don't start canceling yet. I know it's so tempting because you're like, ooh, but wait, this isn't fully factored in the numerator because I still have that addition sign. So factor it completely. I would always tell my students, don't throw the cancel party prematurely. Canceling's so fun, right? It's so satisfying. It's like a party in math, but don't do it too soon. Now I'm allowed to. Why? Because see how there's no more addition? This is fully factored. It's just factor, factor, boom. So now is an appropriate time to throw your cancel party. Look at us. Woo, that was so fun. Okay, then we've got the limit. X approaches 3, 2x squared plus 5 over 5x plus 3. And then we should be good to go. So using direct substitution now, this is 2 times 3 squared plus 5 over 5 times 3 plus 3. So 2 times 9, 18 plus 5, 23 over 15 plus 3, that's 18. And that's it. Okay, so hopefully you feel more comfortable now factoring out the greatest common factor, factoring by grouping, and factoring trinomials. Obviously, there's more factoring techniques you need to learn, like factoring a sum and difference of cubes, difference of squares, all sorts of stuff. That's coming soon. This was just part 1. And then I'm going to work through the entire calculus course and go over whatever algebra skills you might need refreshed, and then show how they apply into your calculus problems, into the content of calculus. So the purpose of these videos is not to give you a calculus lecture. I already have all of that done for you. But a lot of students sometimes have taken a break while they're in school, or they've just forgotten because these aren't things you use all the time unless, you know, you're me or you're tutoring on the side. So I just want to help bring everybody up to the same page. That way the algebra isn't holding you back from succeeding in calculus. Okay, thank you guys so much for your support. Don't forget to give the video a thumbs up, subscribe if you haven't already, and you can also follow me on Instagram, TikTok, Math with Professor V. I'll be back sooner than later. Bye.